Ladies and gentlemen, may I introduce for you Mr. ge.hulsmans with this webinar.
Hello, many thanks. Good afternoon, good evening, good morning, wherever in the world you are. Please be welcome to the second webinar eldoLED about dynamic lighting and at the same time optimize the quality of light. We're airing here from our headquarters in the Netherlands. For those of you who don't know me, my name is ge.hulsmans. My job in eldoLED is to teach lighting designers all over the world about LED drivers, about how to create good light, about proper dimming, about flicker. And today I will, as said, teach you about how to specify and design dynamic white lighting. And the agenda of today is as follows. First, I will take you on the route on what is tunable white, what is human-centric lighting, how to specify it. I will take you back to high school to teach you about the definition of color. How do we talk about color? What are several ways to define it? I will teach you about a new DALI standard, DALI-2. I will give you an example on several painters creating a certain color, and I will make an analogy towards white light. Immediately linked to that, I will go further and teach you about DALI Device App 8, a relative new lighting control language that helps you to define colors in a better way. And then I will immediately move to something clever that we've integrated into our drivers, which we call light shape. That is basically to make a consistent lighting over different luminaires when it comes to the dynamic approach. I'll stop with a small video, a demonstration, and then I'll come to a conclusion. And afterwards, we will have a short Q&A session, which goes online, I believe. And that's the agenda of today. It will take approximately half hour, possibly a little longer. Make yourself comfortable, take a coffee or something, and relax, and try to enjoy this webinar. Right, let's make a start. So, dynamic lighting, dynamic white lighting, human-centric lighting. Basically, daylight, that's an important topic for many lighting designers all over the world. I mean, in essence, what you do every other day as lighting designers is to make sure that you incorporate daylight into your work environments, into the work environments of your customers. And daylight is good for us. We need light, we need darkness, and basically the lighting designers work to create light that basically supports the need for this illumination and darkness cycles. That is valid for natural light, obviously, but it's also valid for artificial light. And when we talk about artificial light, it's about changes in intensity, proper dimming. It's about changes in colors. Well, whatever, dynamic approach, and the directionality of light is crucial too. Where does the light come from? I mean, the sun shines from above, and campfires in the old days, obviously, they burn from below. And this is something that has an impact on how people feel. A designer is always working on design for daylight. Is there access to sunlight? What about flexible shading? Is there access to an outside view in work environments for your customers? Is there some form of control? How does the user can interact with this light? Is there some daylight, automatic responsiveness? Is there personal control in order to make it happen? And if it's been decided to go for electric light, why can't it be that your electric light is as if it was the sun? Why can't your electric light be with a certain dynamics? The training of today is basically to teach you some basic knowledge when it comes to implementing this solution and how to actually create this. This is the most important topic of today. I'm going to take you back to high school, and I'm going to teach you about how colors are actually defined. And let's first take a look at this, the color triangle. I'm sure everybody knows this. With the black body locus in the middle as light as the ideal white light. Some people refer to light as the sun. Where you see the curve, that is the black body locus itself, and then you have vertical stripes on that curve, and that is basically the Kelvin degrees lines. And this is immediately the first way in which we can define color. The first way in which we can define color is by a certain color temperature, by a certain Tc in a degrees Kelvin. And that's the vertical line on the black body locus. So we have 4,000 Kelvin, 3,000 Kelvin, 2,500 Kelvin. And as said, it's a line and not a point. So that means that if you have two lamps or two lights that both give 4,000 Kelvin, there could be a difference in the way the human body, the human eye actually perceives it. It can be a little greener or a little reddish. I never know how to put this in English, but there can be differences. It's not really exact. The second way in which we can define color is by a very specific XY coordinate in this color triangle, and that is much more exact. And there's a third option, which is, and by the way, this XY is called chromaticity. And then the third option is the color space, and this is where we include the third X, the ZX, which is called color space, and this includes intensity as well. So this defines three ways in which we can talk about color, and this is crucial if you are going to specify dynamic light and tunable white as well. Right, let's make it a little more difficult, and I just talked about one color, but now we're going to make it tunable, and we're going to create light that changes color from, let's say, 4,000 Kelvin to 2,000 Kelvin. So you have two lines in the in this graph. If you don't have any information on where the light comes from, on where the LEDs are actually located here in the color triangle, it could well be that the dynamic cycle runs from here to there, from both on the black body locus, and then you have a straight line that works moves like that. But if no information is actually known on where they are on the black body locus, if you don't know have any information about the LEDs, it could well be that the dynamic route goes from this line to that line. That gives a completely different dynamic approach, or from here to there, or from here to there, or completely different. And all of these routes are different, and this creates a certain inconsistency that obviously you would like to avoid. So this is something that you have to keep in your mind when you start specifying light. This comes later. Save this knowledge for later, because I'm going to basically go to the next topic, and the next topic is DALI. As you know, DALI is an important standard when it comes to lighting. It means a digital addressable lighting interface, and I would say in Europe and in Asia, it's one of the most important lighting control protocols that exist. The official name of the standard is the IEC standard, the 62386 standard, and you see here in the top that there is DALI and DALI-2. I'll explain DALI-2 later. What I would like to teach you today is basically that there are several well, let's say, dialects, if you wish, for DALI. And in the old days, when you wanted to specify DALI for fluorescent light, you needed to use the standard which was called device type 0. It was also called the 201 standard. And for HID, it was called device type 2, the 203 standard. And for LEDs, most drivers that are currently being most DALI drivers that are currently being used follow the device type 6 standard, the 207. That is actually meant for monocolor LEDs. It is used for tunability as well. I'll get back to how you do that later. But today, there is something new. And the new thing that DALI has come up with is the device type 8 standard. And the device type 8 standard is actually a standard that helps you to define a certain color. And that is relatively new. Now, some people think that there is a difference between DALI and DALI-2, and DALI-2 is basically nothing else than a new certification program for the DALI standard. DALI exists for a long time already, and up till, I believe, 2 or 3 years, an international organization of lighting manufacturers became in charge of that new DALI standard. And the new DALI standard was called DIA. The new DALI standard was called DALI-2, and the international organization was called DIA, the Digital Illumination Interface Alliance. And they are in charge of the DALI standard. And whenever they release it, they're going, in the old days, basically, the DALI standard was ready, the learning book was ready, but in the old days, there was actually nobody checking if control gear that came up the market actually complied to that standard. And this is what the new DIA organization changed, and they basically said, we're not going to only make a learning book, but we're also going to make an exam for all of these drivers. And this is where DALI-2 comes in. So DALI-2 is nothing else than a new certification program that basically helps to get back to, well, the basic idea of DALI, which is an improved interoperability between several brands. So that an eldoLED driver works together with controls from several brands, and that they all basically function the same. So DALI-2 is a new certification program that actually works that way. It is not designed by default to solve any color-related issues, because color and tunable colors, there you need something else. And what you need something else, that is later. Let's get back to the topic of today. And the topic of today is dynamic lights, tunable white, and the creation of that. And let me give you an example in this hotel room. Now, many designers, many lighting designers are in the call today. And suppose you need to, you've specified this hotel room. What you see here in this room is some downlights. You see cove lighting. You see lights behind the bed. And many times in your projects, you use several manufacturers. And if you are going to create a tunable white light, dynamic lighting, what you actually would like is a consistent dynamic route of all of these lights in your projects. And when you're using different manufacturers, this can be a real challenge. And this is exactly what I'm trying to teach you today, how to solve this and how to make this work better. And in order to do so, I am going to introduce to you the fact that if you create tunable white light, you're mixing basically two types of LEDs, a warm white and a cold white LED. And in order to explain that easy, I'm going to give you an example of a hotel shower. Because in a hotel shower, I travel a lot, and every time you need to go to a different hotel room, and there are different taps and showers. And what you need to do is mix the water, mix cold and warm white. Mix cold and warm water. And if the tap is off and you don't have any water, you can't shower, obviously. If you switch the cold water on, you have a good flow of water, but obviously the temperature of the water is not good enough. The same for the hot water. If it's too warm, you burn yourself, and you have enough water, but it's too hot in order to make it happen. If you put them both fully on, then, well, the temperature might be okay, but it's like taking a shower on the Niagara Falls. You just have far too much water. It basically hurts your body. The basic idea is to create the right mix of warm and cold. You fiddle around with the taps, you have the right mix of warm and cold, and then the temperature of the water and the amount of water is actually exactly right. And if you have to do that in with many taps, every time you have to fiddle around and to make this work. And this is exactly the analogy I would like to use if you're going to make tunable white, because every fixture, every LED is different, and you need to fiddle around by mixing the right ones in order to get the right amount of light under the right color temperature in order to make it work. And this is the analogy. Dynamic white lighting. It's like dialing and making sure that you take your morning shower every other day. Right. Let's make the move to lighting. I'm going to give you the following example. Imagine there are 4 painters, and I give every painter a palette. And on that palette, I'm giving every painter a tube of paint, a tube of blue paint and a tube of red paint. But every paint is from a different manufacturer. So different types of red and different types of blue. And I give those 4 painters an assignment. Could you please create the color purple for me? So they go into their own rooms, and after a few seconds they come back, and they've mixed those colors, a little bit of blue and a little bit of red, and they've mixed that, and they come back to me. And the chance of that every painter has created the same color purple is virtually 0. Because basically what we need to do, every color, any tone of purple has a different, every color purple has a different tone, if you wish. So what we need to think of, if I've given the assignment, is basically a definition on the color purple. So how do we define the color purple that he needs to create? That's one. And secondly, how should he mix those colors based on the knowledge of tube of paint that he has. And those two questions we need to answer as well if we're going to create consistent tunable white lighting in light. Two topics, the definition of the color. This is what I will discuss now. And then later we move on to the color mixing algorithms. Right. Now let's move to the most important topic of item of today. That is the definition of the color. And this is where DALI comes back into the game. Before we had DALI device tab 8, when we wanted to create tunable white light and DALI-6, what we actually did is we connected one driver to a cold white LED, another driver to a warm white LED. We had a clever controller and we started mixing the colors. We dimmed the warm white up and down and we dimmed the cold white up and down, and we mixed those colors cleverly. And by mixing them cleverly, well, obviously you didn't know which color that you were creating. So what happened actually, though, you took an external color meter, you measured the color, you mixed until, I don't know, you achieved 3000 Kelvin, and that information was then stored into, let's say, the DALI controller. And that scene was saved, 3000 Kelvin, under this button. And if you wanted a different color, you mixed again till you've reached another one, and this is how it actually went. By mixing colors, by adding a driver and dimming them up and down, and by doing so creating a tunable solution. Well, from the early days of eldoLED, we did something extremely clever. We created one driver that basically incorporated those two channels. So you could get rid of one driver, and we introduced our dual drives, but the simple idea was still the same. We mixed colors, we measured it manually, and we feed this information back into the controller. Right. Now, there is obviously something new that I've talked to you about earlier. This is DALI-2 device tab 8, which is a newer language. It's a richer language than DALI device tab 6. And basically, one of the most important differentiators here is that you need only one DALI address to steer both intensity and color temperature. The color temperature is actually added to this language, and this is new. This helps you to better define the color. This is a great example. In setting the colors, there are actually, well, it says 4 here, but there are actually 3 color types that that the DIA has defined, and one of those 3 color types is the TC. So that DALI controller can actually ask for a certain color temperature in a certain degrees Kelvin in a TC, and that is basically one of the 3 that is available. So the learning book for all of the 3 color types are available, but only one has been officially released by the DIA. The other ones, the XY coordinates and the RGB-WAF, they will be released later. That's not up to us, that's up to the DIA in order to make that happen. Is the TC an ideal way of communicating? Well, it's okay. It is a line and not a point, so it's not exact, but it's much better than we ever had before, because in the old days we were basically mixing it and measuring it with a color device. Later, DIA will come up with XY and RGB-WAF as well in order to further improve the situation. Within eldoLED, we really follow that DIA standard in order to don't get into troubles when you talk about compatibility between controllers and drivers. So we're extremely happy that DIA actually announced this new standard, and this is what we are following in the DT8 standard. So a little bit of summary: when we compare DALI-6 and DALI-8, in the DALI-6 standard, you needed 2 addresses, one for the intensity and the other for the color temperatures, where in DALI-8 you only need 1. In the DALI-6 arena, you need a manual calibration with a color meter, and in DALI device tab 8, you don't need that because, well, you can actually ask for a certain color temperature. So we follow the DALI-2 DT8 Tc standard as such. Right. Now, is this enough? Is it enough to basically ask for a certain color temperature when you don't know which LEDs are actually connected? Let's get back to the painters. You don't know which type of paints that are actually in those tubes. You don't know which LEDs are actually connected if you do a certain project. So my reaching out to you today is that DALI-8 is it's only phase 1 that you need to specify. You need to specify something else. You need to specify a clever color mixing algorithms that you create that consistency. You need to make the system color aware. And in order to do so, you can ask for a certain color temperature. That's what DALI arranges. And then that the system actually makes sure that you're also going to get it. And this is what we further integrated into our drivers, further cleverness into our drivers, which we call light shape. And that's what we call color mixing, and a clever color mixing algorithm, which is automatically integrated in many of our drivers. Right. A little sidestep again. Everybody knows that if you dim your light, that the human eye is extremely sensitive in the low areas. Because if you have not a lot of light, the pupil of the human body actually increases, and that has the capability to basically make sure that all that light actually comes into your eye. In color changing stuff, it is exactly the same. The human body can see color differences pretty well. The human eye, you have cones and rods in your eye that basically make that happen. But I'm going to introduce to you the macadam ellipsis in the color triangle, because the macadam ellipsis is a region in this color triangle. And let's go to this region. Let's go to this macadam ellipse here. A macadam ellipse is a region in this color triangle that basically defines that if you are in that region, that the average human eye can't see any visual differences in color if you're in that ellipse, or if you're in the top or in the bottom, it's all the same green. But now look at this. There is something interesting that is ongoing. Obviously the colder the colors become in the color triangle, the smaller the ellipses become, and the smaller the ellipses become, in fact, it means that the human eye is more set. It's easier for the human body to actually see those color differences. And well, opposite, if you have warmer colors, the macadam ellipses are bigger, and then it's basically less visible for the human eye, those color differences. And everybody knows that. Every lighting designer knows that in cold colors, it's tougher that you quicker see color differences as such. This has been explained by the macadam ellipses. Let's get back to the color mixing algorithms that we have incorporated. Consistency in color perception, that is what we're trying to achieve. Yeah, let's get back to the hotel room where you would like downlights and panels and cove lighting to be exactly the same. Now, all the tubes of paint are different. Every LED is different. Every LED has different technical characteristics when it comes to, a different type of current, a different amount of current, give different light levels. Every LED has been made differently when it comes to tunability, of course, when it comes to color control. And what we've integrated into our driver is cleverness. We call that light shape. And what we actually do, we tell the driver which LEDs have been connected, so that the driver knows what LEDs are connected. And if DALI device app 8 then asks for a certain color temperature, the clever color mixing algorithms integrated into our driver arrange a consistent creation of tunable light. And if you wish, we call this an automatic calibration. You don't need this manual calibration anymore with an external color meter, but you need this to be this is done automatically. And this is cleverness integrated into the LED driver. So it is basically a light shape is a combination of a driver, some hardware, so a broad range of dual drivers that actually incorporate this information into the driver itself, firmware that basically arranges the dimming, the proper proper story on flicker, and software, because we need to program this driver as well. And the programming of this light shape goes via a well-known flux tool interface, and that helps to basically tell the driver which LEDs are actually connected. So it's an integrated solution that makes your total system color aware, and it ensures that you have a smooth and deep dimming, perfect consistent color changing rhythm over these LEDs as such. With one basic idea is that you create 4 painters have 4 luminaires, a certain number of luminaires with those same colors purple, with those same dynamic approach when it comes to the tunability of light. Right, and in order to kind of summarize what it is that I'm trying to teach all the lighting designers here, if you really would like to go into tunable white, dynamic white, make sure that you specify DALI device type 8 Tc with light shape, where color science is actually embedded in the controller. The controller asks for a certain color temperature, the clever LED driver is calculating it and illuminates it correctly. Right, what I will show you now is a short video on the actual working of light shape. Heino, could you please start that? Let me demonstrate light shape for you now. I have here 2 completely different LED modules, so-called CSPs. The first module can travel from warm to ice cold, from 2700 to 6500 Kelvin, and the second LED module can travel from deep warm to neutral, from 1800 to 4000 Kelvin. Look at both models when they're not illuminated. You see 2 patterns of several colored LEDs in one package. The 2 patterns are completely different. Now we've attached to these 2 LED modules a dual DALI driver each. These 2 DALI drivers are equipped with light shape technology. The driver types are the same. They look the same, but they're programmed or profiled differently. They have different light shape profiles inside. Objective of these 2 different light shape profiles is to make the cycle from cold to warm and back, the dynamic route, the same. The objective is the creation of consistent dynamic light. Although the LED have different default routes, you see now that the travel from cold to warm and back is identical. The overlapping route is the smaller path from 2700 to 4000 Kelvin. This is the route that we are demonstrating. So look closely into these LEDs when they're dimmed down to really low levels. If we start the dynamic cycle from cold to warm and back, you see something stunning. You see that the mixing is done differently, but the light effect is exactly the same. This is what light shape arranges. Different LEDs mixed differently via light shape and still a similar dynamic color behavior. Consistency achieved, mission accomplished. We are mastering light. Thank you. So that was the video. A little summary of this video. I've created 2 pictures of the video of the demonstrator. So basically 2 completely different CSPs, chip scale packages with different routes. We've connected 2 dual drives to one dual drive to the first LED and the second dual drive to the other LED, and what we've connected a dual slider to it, and by showing you the situation in how the LEDs are actually being dimmed and how the LEDs are actually mixed. On the left hand side here, you see the dimming when the warm light is on, and you see that they're mixed in a certain way, and on the right hand side you see that when it's dimmed to the cold way, and then you see that the actual dimming is different. Important, obviously, to say that the dynamic route of these 2 solutions is identical. You have the same dynamic behavior via different color mixing algorithms that we arranged in the driver, and this is what we call light shape. So again, summary, we are going to close down. I believe I have 2 more minutes to close down. First of all, I would like to thank you all for participating in this half hour. I hope you learned something from me. The main conclusion of today is, if you as a lighting designer would like to go into creating or specifying dynamic white lighting, tunable circadian lighting, please specify DALI-2 device type 8 Tc, one of the 3 that is available, in combination with a light shape approach with clever color mixing algorithms, and that creates a very clever consistency. Should you have any further questions, feel free to type them in via the Q&A session. I don't know if there were any questions popping up. not yet, doesn't matter. You can also send me an email or send an email to eldoLED. We're here for you to help you in this approach. I would like to close down to thank you all for coming here, and I would like to thank the eldoLED team to make this happen. So Stefan Weideven and Heido de Heide, thank you for helping me to get everything technically sorted, and Mark Kramer, who arranged everything by sending out the invitations and making sure that everybody could actually join this session. Once again, many thanks for joining me today, and I'm sure I'll talk to all of you soon. Talk to you later, and bye-bye.